Somewhere in the universe, there is a single point where the laws of physics, every rule that has worked perfectly in every other place we have ever looked, simply stop. Not slow down, not get complicated, stop. And the strangest part is that we know exactly where this point is. We know what creates it, and our single best theory of how reality works does not just predict that it exists, it predicts its own death there. So here is the question. This whole video is built around, where is the one place in the universe that physics stops working? Why does it break at that one spot and nowhere else? And what does it mean that the cosmos has a location the rules refuse to enter? The answer is sealed inside the darkest object that exists, and it may be the exact same wall that hides where everything, including the ground under your feet, and you, actually came from. Stay with me. Because to understand the one place the rules end, you first have to understand just how unreasonably well those rules work everywhere else. The laws of physics are almost offensively reliable. The same equations that let us drop a probe onto a comet moving through space at tens of thousands of miles an hour also describe galaxies billions of light years away that we will never touch, never visit, and never see up close. We aim our instruments at the very edge of the observable universe, and the same rules that govern a falling apple are still running, unchanged, across a distance so vast that the light reaching us tonight left before the Earth even existed. Physics does not get a vote on where it applies. It works in your kitchen. It works in the core of the sun. It works in the heart of a galaxy 100 million light-years away, everywhere. The rules are the one thing the universe never seems to break, which is exactly why the single exception is so deeply disturbing. And to find it, we have to go to the one kind of object extreme enough to push those rules until they finally snap. Hold one word in your head as we go. Infinity. It is going to matter far more than it should. And to understand the object that breaks physics, you first have to understand how the universe builds one, because nothing in nature wants to make a black hole. For most of its life, a giant star is a war between two enormous forces locked in a perfect standoff. Its own crushing gravity is forever trying to collapse it inward, while the nuclear fire roaring in its core pushes furiously outward. For millions of years, those two forces hold each other in a glowing, stable balance. But the fire needs fuel, and the day a massive star finally runs out, the outward push vanishes in seconds. Gravity, which never tires and never stops, wins the war all at once. The core caves inward, and for the biggest stars, nothing in the known universe is strong enough to halt the fall. The matter collapses past every limit, crushing down and down, until it carves a region of space so deep that not even light can climb back out. The star does not explode into a black hole. It falls into one, and what it leaves behind bends the fabric of reality itself. To see how, you have to throw away something you were probably taught in school. Gravity is not really a force reaching out to pull on you. According to our best understanding, gravity is the shape of space and time itself. Every object with mass bends the space and time around it, the way a heavy ball bends a stretched sheet. And everything else simply follows those curves. You are not being pulled to the floor right now. You are following a bend in space-time that the Earth's mass has carved beneath you. You don't feel it because, for something the size of a planet, the bending is gentle and smooth. But pile up enough mass into a small enough space, and that gentle bending stops being gentle. It steepens. It deepens. And in a black hole, so much mass is crushed into so little room that the bending of space-time becomes a cliff. A slope so steep that not even light, the fastest thing there is, can climb back out. The edge of that cliff has a name: the event horizon. It is not a wall or a surface. There is nothing solid there to touch. It is simply the distance at which the cliff becomes too steep to escape, the line past which you would have to travel faster than light to get back out. And since nothing can travel faster than light, nothing gets out. Not a spaceship at full power, not a radio signal, not a single particle. For a long time, the event horizon was something we could only calculate, never see. Until, remarkably, we managed to photograph one. In 2019, a planet-spanning network of telescopes called the Event Horizon Telescope released humanity's first-ever image of a black hole, a glowing ring of bent light around the dark heart of a galaxy called M87, a monster 6.5 billion times the mass of our Sun. Then, in 2022, they captured the one at the center of our own galaxy. Strangely, the closer one was harder to photograph. The gas around it whips around so fast that the whole image was rearranging itself in minutes while the telescopes were still watching. We can now take a picture of the edge of the abyss. But the edge is not where the rules break. The event horizon is only where they begin to bend in ways that should unsettle you. And the first rule to bend is the one you would least expect. Time. Right at the edge of a black hole, time itself stops behaving. To someone watching you fall in from a safe distance, your clock would appear to slow down as you approach the boundary. Slower and slower and slower, until, at the very edge, you would seem to freeze in place and hang there, fading forever. Time, the one thing we treat as universal and unstoppable, the thing that drags every one of us forward at the same steady pace, becomes negotiable here. It bends, it stretches. For you, falling, time would feel completely normal. But you would look back out and watch the entire future of the universe play out in fast forward in your final moments. That alone is one of the strangest things in all of science, and it is still only the edge. The rules do not truly break at the horizon. They break deeper. Keep falling. Cross the event horizon, and something happens that almost no one outside of physics has ever heard, and it is stranger than any science fiction ever written. Space and time trade places. Let me explain what that actually means, because it sounds impossible. Out here, where you are right now, you can move freely through space. Left, right, forward, back, you choose. But you cannot choose your direction through time. You are dragged forward into the future, toward tomorrow, toward next Tuesday, and there is absolutely nothing you can do to avoid it. Tuesday is coming whether you like it or not. Now here is the part that breaks the human mind. Inside a black hole, that flips completely. The center of the black hole stops being a place sitting somewhere down there that you could try to steer around. It becomes a moment in your future. As unavoidable as next Tuesday is to you right now, you cannot avoid the center any more than you can avoid tomorrow. Every direction you could move, every way you could fire your engines, every choice you could make, they all lead to the exact same point. Because that point is no longer a place in space. It has become your future in time. The geometry itself has turned the center of the black hole into your destiny. There is no escaping it. Not because the pull is too strong, but because the universe has rewritten what forward even means. And as that destiny rushes toward you, the black hole begins to take you apart. In a way so vivid, scientists gave it an almost comical name: Spaghettification. Because gravity grows so much stronger over even tiny distances near the center, the pull on the part of you closest to it becomes wildly stronger than the pull on the part farthest away. If you fell in feet first, your feet would be yanked harder than your head. And the difference would grow so violent that you would be stretched like a piece of taffy into a thread thousands of kilometers long, while being crushed inward from the sides at the same time. Every atom drawn out into a line, falling toward a point that is no longer a place, but a moment. And the density of everything around you climbs toward something no instrument has ever measured, and no theory was ever built to survive. You are approaching the center. You are approaching the one place. Before we reach it, I want to hear from you. Tell me in the comments where you are watching from, and whether you believe humans will ever crack what waits at the center of a black hole, or whether some doors in the universe are meant to stay shut forever. I genuinely want to see where people land on this one, because the answer has split the smartest people alive, and it is about to split everything we thought we knew. At the very center, our best theory of gravity, general relativity, the same theory that has passed every single test we have thrown at it for over 100 years, makes a clear, specific prediction. It says that all the mass of the collapsed star, an amount of matter greater than our entire sun, is crushed down into a single point of zero size. And a real amount of mass squeezed into zero size means something the human brain is not built to hold. It means the density at that point is not just enormous, it is infinite. The curvature of space there is not just steep, it is infinite. And here is what you have to understand about infinity in physics. It is never, ever a real answer. When the mathematics hands a physicist infinity, it is not describing a real, infinitely dense object sitting out there in space. It is the equation itself raising its hand and surrendering. It is the theory saying, out loud, I have failed. The question you have asked me has broken me. I cannot tell you what is here. That point has a name, a singularity, and it is the one place in the entire universe where general relativity, the crown jewel of physics, predicts its own complete collapse. This is it. This is the one place physics stops working. Not because we are not clever enough yet, because the rules themselves run out. But the real question, the one that keeps physicists awake, is why. Why does the most successful theory in the history of science fall apart at this one spot, and absolutely nowhere else in all of creation? And the answer is one of the deepest open wounds in all of science. The truth is that we do not have one rule book for the universe. We have two, and they do not agree. General relativity governs the very big: stars, galaxies, planets, the grand bending of space and time across the cosmos. Quantum mechanics governs the very small: atoms, particles, the strange flickering world that exists beneath everything solid. And both of these theories are not just good. They are two of the most staggeringly accurate descriptions of reality humans have ever produced. Quantum mechanics has been tested to a precision so absurd, it is the equivalent of measuring the distance across an entire continent and being off by less than the width of a single human hair. General relativity predicted ripples in the fabric of space-time a full century before we ever built a machine sensitive enough to catch one. And then, exactly as promised, we caught them. Each theory, on its own, is a masterpiece. Each one is essentially perfect in its own domain. The problem is that they flatly contradict each other. And across almost the entire universe, that contradiction simply never comes up, because the very big and the very small almost never occupy the same place at the same time. A galaxy is never crushed to the size of an atom. A single particle never carries the mass of a star. So the two rule books stay politely in their own corners and never have to fight. Except in one place. The singularity is the single spot in all of existence where something with the enormous mass of a star, which demands general relativity, is crushed into a region smaller than a single atom, which demands quantum mechanics. At the center of a black hole, you need both rulebooks at once, in the same point, at the same time, and they refuse to agree. We have never been able to make them work together. The theory that would actually describe the center of a black hole, a theory of quantum gravity, a single rulebook that unites the big and the small, does not yet exist. We are simply missing the page. And the singularity is the one place in the universe that forces us to read it. There are ideas, of course. Brilliant people have spent their entire careers proposing what might really sit at the center. Once a deeper theory replaces the infinity, maybe the matter never quite reaches zero size. Maybe it forms something stranger we do not yet have words for. But every one of those ideas is exactly that. An idea, untested, unconfirmed. A guess at a page we have not yet been able to read. The honest answer, the only one the evidence allows, is that we do not know, and we may never be allowed to find out. Because here is the cruelest part. The singularity sits hidden behind the event horizon, and nothing, no light, no signal, no probe, No information of any kind can ever cross back out to tell us what is there. We could build the most sophisticated instrument in human history and send it straight in, and it would vanish past the edge and never report back a single bit of data. There is one faint whisper that escapes, a tiny trickle of radiation that the physicist Stephen Hawking predicted leaks from the very edge of a black hole. But it carries no picture of the center, no message from inside, nothing but the slow, faint news that the black hole is, across spans of time longer than the current age of the universe, very gradually fading away. The one place where physics breaks may also be the one place we are forbidden, by the laws of nature themselves, from ever reaching to find out why. Sit with what that actually means, because it is bigger than black holes. It is not that the center of a black hole is some faraway place we just haven't built a good enough telescope to see. It is that the universe contains a real, physical location where our deepest, most tested, most trusted description of reality runs completely out of words. For centuries, mapmakers used to write, "Here be dragons," at the blank edges of the known world, a marker for the place where knowledge stopped. The singularity is the one spot in the entire cosmos where the universe itself writes, "Here be dragons." And as far as we can tell, it is not a mistake. It is right. But here is the turn that changes the meaning of absolutely everything I have just told you. Throughout the entire history of science, every single time physics has stopped working, it was never the end of reality. It was only the edge of our current understanding, and reaching that edge always handed us a deeper truth on the other side. Physics broke when we could not explain why atoms didn't simply collapse. And out of that breakdown came the entire quantum revolution. It broke when we discovered nothing could move faster than light. And out of that came relativity itself, and our whole modern picture of space and time. It broke at the very beginning of time. And wrestling with that break is still teaching us right now how the universe was born. Every wall like this, when we finally reached it and pressed our hands against it, turned out not to be a dead end at all. It was a door. The singularity is not the place where reality stops. It is the place where the next physics begins. It is a signpost, the single loudest, clearest signpost in the cosmos, pointing directly at the theory we do not yet have, the one that will finally unite the very big and the very small into one complete description of everything. The one place physics stops working is, in a strange way, the single most important place in the universe. It is the one spot screaming at us, in a language we are still learning to read, exactly what we do not yet understand. And there is one final reason this should matter to you. Sitting here, a few hundred years into the entire age of science. The singularity at the center of a black hole is not the only one of its kind. The universe itself began with a singularity. Run the expansion of the cosmos backward in your mind. The galaxies, the stars, the atoms that eventually became this planet and became your body. And every last bit of it converges, around 14 billion years ago, into the very same kind of point. A place where density climbs to infinity, where the curvature of space runs out of meaning, and where the exact same equations break in the exact same way, which means the wall that hides the center of a black hole is the very same wall that hides the birth of the universe. The one place physics stops working is not just sealed inside dark, distant objects scattered across space. It is standing directly between us and the answer to the oldest question there has ever been. Where did all of this, the light, the stars, the world, the ground beneath your feet, you, actually come from? Crack the center of a black hole, and you would not just understand a black hole. You would understand the beginning of everything. So maybe the most human thing about the entire universe is this. It left us exactly one question it will not yet let us answer. A single point, hidden in the dark, where the old rules run out and the new ones must begin. We have stood at walls like this before, completely certain we had finally reached the end of what could be known. And every single time, the wall turned out to be a door. The one place physics stops working might just be the place where, someday, it starts again. And on the other side of it is the story of where we came from. We simply have not learned how to read it yet. If the idea that our very best theory predicts its own death just rewired how you see the universe, you already know what the like button is for. And if you want to keep going, the full journey into a black hole, all the way down to the edge of that impossible point, is waiting on the channel.